Okay, well, let's get started. So we got days 1, 2, and 3 done last time. Let's get started with day 4. So we'll open up the puzzle and let me know if, hopefully these font sizes are big enough for everybody to see. If they're not, let me know and I can make some adjustments. All right, so let's create day 4. And then, like I said, I'll just copy the template in there. Okay, and we'll get started. Okay, so day 4, camp cleanup. Space needs to be cleared before the last supplies can be unloaded from the ships, and so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. To try to quickly find overlaps and reduce duplicated efforts, the elves pair up and make a big list of the section assignments for each pair. And that is our puzzle input for each pair. Oh, okay, the elves pair up and make a big list of the section assignments for each pair. Okay, got it. So each pair of elves makes a list of their section assignments. All right, so here's our test data. For the first few pairs, this list means within the first pair of elves, the first elf was assigned sections 2 to 4, and the second elf was assigned sections 6 to 8. Okay. Elves in the third pair were each assigned 3 sections. Okay. This example list uses single-digit section IDs to make it easier to draw. Your actual list might contain larger numbers. Okay. All right, I think I got it. Some of the pairs have noticed that one of their assignments fully contains the other, like this one. For example, 2 to 8 fully contains 3 to 7, and 6, 6 is fully contained by 4, 6. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections their partner will already be cleaning. So these seem like the most in need of reconsideration. In this example, there are 2 such pairs. In how many assignment pairs does one range fully contain the other? Okay. Okay. All right, well, first let's take a look at the data here. Right, this is what it's going to look like when I import it, except these will be strings. So, I mean, the first thing I'll have to do is parse the strings, and in Python, we have range objects, which I may be able to use. Although it may be easier to convert these into a list. Okay. Yeah, but they're essentially just pairs of ranges. Okay, so let's get the data first, and then and then in this case, I think what I'm going to do is I'm going to do the processing of the, the parsing of the data I'll do in the get input function. All right, so the first thing I'll do here for part 1, I just want to look at see what the data looks like as I work with it. So I'll just say return get input, and then the day is 4 and the year is 2022. Oh, you know what? Let's make this a little bit easier. We'll just set a default value for year since we're not going to be changing that. Let me do that here too. There. So that way we only have to pass it the day. Okay, so if I run this, whoops, it should be a 0, not an O. Okay, yeah, you know what, let's not strip it just yet. Interesting. Okay, there we go. Let's see. So it looks like we're just getting... If I return data 0, I get a 9. That's weird. I'm trying to figure out how this is... 9. Oh, okay. This is all one big string. Let's see if there's an easier way to do this. Lines. Let's see what lines looks like. I'm not sure if this format is the same. Okay. All right, so if I use lines, then it'll put each pair in a separate line. That seems a little easier to work with. Okay, yeah, I like that better. Now, how does it know what day I'm working with? Get input 4. Does it just default to the last one that I haven't solved yet? Maybe. Hey Jay, how you doing? Like data split lines. Tell you what, let's try this. What if I do this? Okay. This I can understand now. All right, so now I have an array of lines. Okay. So we'll do data split lines. All right, so let's call that, I don't know, we'll call that pairs raw equals data split lines. So this is going to give me a string with 2 pairs. Okay, and then we'll do for pair in pairs raw. And then we'll create a new list. Okay. How do I want to bring in this data? So right now I've got pairs of strings like this. Or I've got a list of strings like this. I'm doing good, Jay, thanks. Just getting my brain warmed up here. Okay, so if I split it on the comma, then I can end up with, you know, like 2 strings like this. And I could put those inside another list like that. I'm trying to think of how I can best work with this data. All right, here, let me do this. All right, so for now, I'll just return the raw data. Here, we won't even do this yet. Let's do an experiment. Because I want to see if I can use range for this. So let's see if this works. Can I do B and A on range objects? Okay. Well, it lets me do it, but it gave me false. What if I did this? That's also false. Okay. Let's see what A and B look like when I do that. Okay. Let's Google something. List subset. How can I verify if one list is a subset of another? Using set. Set A is subset B. Okay, let's try that. Report whether another set contains this set. Okay. Then we also get false. A subset of B. Oh, okay. Let's do this. True. Okay. So that works. All right. So it's set B is a subset of A. So what if I convert these both to sets instead of lists? Does that still work? Yeah. Okay. So this is how we can process it. Got it. All right. Let's go back to our puzzle here. Okay, so I need to keep working with the data to get it into an ingestible form, right? Okay, so we have our raw data, which is going to look like this. It'll be a list of strings. So let's just create a new list. Right here, we'll call it pairs. And then we'll go for pair raw in pairs raw. Pair equals pair raw dot split, and we'll split on the comma. Okay, so that'll give us two of these strings that are going to be the individual ranges. And then I need to convert those into numbers. Because now pair is going to be, it's going to be a list of two strings. So let's just say for P in pair, or we'll call it for R in pair, because R is the range. Here, let's call it range string, just to make it easier to understand. Sorry, I'm getting lost here. So we split this. We've got two strings. Now I need to split them again on the hyphen. And then I'll have two strings. And then I can convert those into integers. And I think I'll just make those another list or a tuple or something. Well, it'll be another list. Okay, so R can be equal to the range string split on the hyphen, and there's going to be two values there. I wonder if I can split twice. Like, I wonder if I can do that. Let's try that. Okay, no, I can't split twice. Yeah, because this returns a list, not a string. Okay, so that won't work. I've got too many variables here, right? So the raw pairs, we got it. And then we have this. This is what we want to return. For each raw pair in the raw pairs, we're going to split it on the comma. And then for, or here, let's do this. Pairs append. So pair is going to be a list of strings. P for P in pair, let's split hyphen. Oh, and I think I can do this. Okay, let's see what this gives us. And here I'm just gonna print the input. Let's comment this out. No, it doesn't like that. List object has no attribute split. Pair. Oh, okay. Yeah, because this is a list. Okay. So we're going to have to do this again. For P in pair, okay, now it's not making any sense. Now I'm completely lost. Oh, there we go. Let's try that now. Maybe I've been doing this right the whole time. Okay, so now these are my pairs. Okay, so they're no longer grouped. But I think that's okay. Right, so I got 94.97 and then 31.95, 7.8, 11.95. Okay, so I just have to go through in, you know, work through these by twos. That should be fine. All right, so now I get a bunch of integer lists, which is good. Okay, so let's go pairs equals, whoops, equals get data from day 4. Hey, Mohad. Yeah. First, let me get rid of this guy. There we go. How you doing, Mohad? Yeah, we're doing Advent of Code and trying to solve puzzles. Okay, so let's import our test data, and we'll do it with that. Okay. So let's comment this out, and we'll run through with our test data, which is why does it do that? Okay, which is going to look something like this. Here, let me take that out. I'll just paste it here. I'll have to type this manually, I think. All right, so it's 2, 4. 6, 8. And then we have 2, 3. We have 4 and 5. One, 2, 3. Nope. Okay, and then we're going to have 5 and 7. We're going to have 7 and 9. We're going to have 2 and 8, 3, 7, 6, 6, 4, 6, 2, 6, and 4 and 8. Okay, so that's our test data. All right, and then this is how we can figure out if one is a set of another. Let me check one other thing here. Because if I remember correctly, range does not include the top number. 1, 2, 3, 4, and 2 and 3. Okay, yeah, so we'll have to add 1 to the second number so that it's inclusive. All right, so let's do this. And I need to take these 2 at a time. Hey, Jim. Thanks for stopping by. Do Python ranges have a cover method? I don't know. What does cover method do? We do have this, where we can check if one set is a subset of another one. So this will tell us if one range is within another one. We just have to convert the range to a set. And I'm just using, well, here, let's check something. Does it have any? Yeah, no, there's nothing like that. Okay, so now we just have to iterate through the pairs by 2s. So I'll just say for I in range from 0 to length of pairs, and we're going to go in steps of 2. Okay, so we can say elf A equals pairs I, elf B equals pairs I plus 1. And then we'll say if set elf A. Oh, okay. First we have to convert that to a range. Right, and then like I said before, we need to add 1 to the second values to make it inclusive. Okay, and then we'll need a count variable. So we'll say count equals 0. Okay, so if set elf A is subset of elf B, or the inverse, right? Because we don't know what order these are going to come in. Then we increment our counter, and then we return the counter. Okay, so let's see how this goes. And we get 2, which I think was the correct answer. Yeah, there are 2 such pairs. Oh, okay. Oh, thanks, Mohad. Yeah, I'm not sure. I don't know anything about Ruby, Jim, but yeah, the subset. Well, when you convert a list to a set. Oh, you know what? Could this be a problem? Because a set does not allow duplicate values. All right. So if A is a list consisting of 2 of the same numbers, and I make a set out of that, I get a set with 6 in it. I think that doesn't matter, though. That's fine, right? That works in this case. That's the difference between a set and a list. A set is a set doesn't allow duplicate values, and a list does. Yeah, so I think this will. I think this should work. I think this should work. All right, so let's comment that out, and we'll try it with the real data. I'll save that test data there in case we need it for the part 2. Okay, and I'm getting an error. Oh, you know what? Let's try it again. Okay. Yeah, I'm getting an issue now with with pulling the data like this. And I think it's because I'm hitting the API. I hit the API every time I run this, and I think it's giving me a problem. Yeah, it's not even. I might have to go back to the old way of pulling in the data. Yeah, let's just do that. I think we'll just have to continue using data files. All right, so let's just we'll have to copy paste it. See, if I was better, I would only need to hit it once or twice, and then I'd be in good shape. But let's see. How do I change? Yeah, Mohad mentioned the theme. Let me check what theme am I using. In case when I use this. Workbench. No. Text editor. Tomorrow Night Blue is the theme that I'm using. In case you're interested. Yeah, I like the colors. Okay. Yeah, so we'll change this back to a file name input. Okay, so in this case, we will be getting data from inputs, day04.txt, and I made that same mistake again, day04.txt. And this is get input. I know where I went wrong. Never mind. Let's change this back. It's because I'm saying get data, not get input. This has to be get input from day 4. I think that's where I'm getting the error. There we go. Okay, 567. Let's see if that's right. Come on, baby. All right. Whew. That was somewhat painful, guys. Yeah, just getting the data, getting this data into a usable format was really the most difficult part of this. Okay, but we got the right answer. Okay, so then we'll go into part 2. I'm going to copy the same thing here. Yeah. Yeah, honestly, that's one of the biggest challenges that I run into sometimes with the advent of code stuff. Okay, so this is how it would look without having the test data included. It's a bit more precise. All right, day 4, part 1. So I'll put this in the repo in case anyone wants to look at it. And I'll post a link here again too. Hey, thanks for stopping by, Jim. I'll see you. Have a good weekend. Okay, let's look at part 2 now. And now they're going to say, before I even read it, let me guess, they're going to say that, oops, that's not the data we really wanted. We wanted something different. And this is where sometimes it makes it difficult. Like, depending on how you write your code, sometimes what you do in part 1 is directly usable in part 2. And sometimes you'll get to part 2 and then it makes you want to rewrite what you did in part 1 to make part 2 easier, but we'll see how it goes here. It seems like there's still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. Okay, so now we don't necessarily need subsets. We just want to know if they overlap at all. Okay, so an overlap would be like if even one number is the same. Like, for example, 5 to 7 and 7 to 9. These are not subsets of one another like we were looking for in part A, but they do overlap on the 7, right? Okay. I think this might actually be easier. Okay, so let me comment this out, and once again we'll work on it with our test case first, and then we'll get the answer. Okay, so I'm gonna copy what we did in part 1. Right, so we're not going to be looking for subsets anymore, so we can get rid of that. Elf A and Elf B. Do we still want to do ranges? I don't think we want to do ranges anymore. So in this case, let's just say Elf A equals pair 0. Or no, I'm sorry. Pairs I and Elf B equals pairs I plus 1. Because now what we can do is we can just see whether how would we see if there's any overlap? For example, in this one, if the minimum of this one is if the maximum of the first pair is greater than the minimum of the second pair, then there's an overlap. or if it's equal to. Yeah, you know what? I think there's got to be an easier way to do this. Let's Google it. Python list, let's say Python range overlap. Check if two integer ranges overlap. Two ranges overlap if the larger of the start values is less than the smaller of their stop values. Okay. So let's do, yeah. So let's do stick with the ranges. Okay. So we're going to say if the maximum of elf a dot start and elf b dot start is less than the minimum values of elf a dot stop, elf b dot stop, then count plus or equal to 1. Yeah, you're probably right. Okay. Let's try to do it that way then. Let's try to do it that way. So elf a equals pairs 0, elf b equals pairs 1. So if the minimum of elf a is greater than I think I'm gonna have to check 4 different combinations, right? See, the thing is, I know that I know that creating ranges is going to take some cycles, but also every time I check a min or a max, that's like an O of n time complexity too. So if I check, and I think I'm going to have to check 4 different conditions, right? I'll have to see if the minimum of this one is greater than the minimum of this, or if the maximum of this one, yeah, let's just do it. Let's just try it this way. But then again, checking if the start, and these are always going to be in order, right? Like if we look at our input data, it's always, the first one is always the starting value and the second one is always the ending value. So I wonder if I even need, I don't really need a range, do I? Because elf a start is just the first number in elf a, and elf a stop is just the second number in elf a. So I don't need to create ranges at all. right? So I could just say elf A, whoops, elf A 0 and elf B 0. And elf A1 and elf B1. So if the maximum of their two start values is less than the minimum of their end values, then they overlap. So let's test that logically. In this case, what is the maximum of their start values? It's 7. Is it less than the minimum of their end values? It's not less. In this case, it would have to be less than or equal to. Yeah, and I think that's going to do it. So part 2, and I get a 0. Oh, duh. This has to be I and I plus 1. My bad. Try that again. Okay, and I get 4, which is the answer we're looking for. Okay, so let's comment out the test case, uncomment the actual case, and I get 907. Yes, okay, awesome. All right, that wasn't too bad. Oh. You know, I watch some guys on YouTube doing this, and they do it in like a minute with like 2 lines of code. And then, how long have I been doing this now? This took me like 45 minutes. But I got there. That's the important thing. I'm going for correctness, not speed or efficiency. Yeah, right. Okay. All right, let's do another one. Hopefully the next one won't take that long. We'll see. All right, day 4, part 2. And we'll commit and push. Yeah, and you know, I think if you dedicate a lot of time to doing these type of puzzles, you get to be really efficient at it. Like even just like getting accustomed to how the puzzles are written and how the how the input data is presented and stuff like that. Like you can get a lot faster with it. Okay, but anyway, we got a correct answer. That's what counts. All right, so let's do day 5, and we'll take it from there. All right, so let's copy the template. I could probably just, close day 4, and then let's make our input file. Good Lord. Whoops, wrong button. Okay. All right, let's see what the puzzle says. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. Okay. The ship has a giant cargo crane capable of moving crates between stacks. To ensure none of the crates get crushed or fall over, the crane operator We'll rearrange them in a series of carefully planned steps. After the crates are arranged, the desired crates will be at the top of each stack. Okay. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and the arrangement procedure. Okay. In this example, there are 3 stacks of crates. Stack 1 contains 2, stack 2 contains 3, stack 3 contains 1. Crate Z is on the bottom, crate N is on the top. Okay. Then the rearrangement procedure is given. So move 1 from 2 to 1. So here D, I guess, gets put on the top. Move 3 from 1 to 3. Oh, move 3. Okay, and then we move that whole stack from 1 to 3. Okay. I get it. And then at the end it looks like this. Okay, in the first step, so in the first step, it just moves 1. In the second step, and then it looks like this. In step 2, three crates are moved from stack 1 to stack 3. Oh, crates are moved 1 at a time. Okay, so first it moves D, and then N, and then Z. And then we move 2 from 2 to 1. So first C, and then M. Okay. The elves just need to know which crate will end up on the top of each stack. Okay. This one is interesting. Right, so we'll have to set up our stacks. All right. So let's, like we did before, let's start with the test case. So I'll just copy this. Here, let's do this. Get test data. And I'm going to want to return. I'm going to want to return 2 things from here. Right. So first we'll have the stacks, and the stacks will do like a list of lists. Okay, so stack 1 will be, and we'll do it from the bottom up. So we'll do Z and then N. And then stack 2 would be M, then C, then D. And stack 3 is just P. Okay, and then the instructions, whoops, will be another list. This is like just as bad as the autocomplete on my phone. All right, so I'll just convert these all to strings. Okay, and then we'll return stacks and instructions. Okay, and we'll do something similar for the live data as well. Okay, and then I'll make another function. We'll call it parse instruction. Right, so that way we can turn this into something usable. So I basically just want to extract these 3 numbers from the instruction. Oh, I'm in the wrong place. All right, so I don't know, we'll say instruction list equals instruction dot split, and we're going to split on spaces. And then we'll return, here, let's just make this smaller to make it easier. We'll call it I. And we're going to want to return, this will be 0, 1, 3, and so we'll want to return 1, 3, and 5. And we need to make these integers like that. Okay. So this way I can, as I go through each instruction, I can parse it to get those integers. Okay, so let's just test to make sure that this works. So we'll call stacks and, whoops, and in instructions equals get test data. And we'll say print stacks. And then we'll say for instruction in instructions, print parse instruction of that instruction. So let's just see if we get if we get stuff in the format that we're going to want. Okay, that looks good. So those are our stacks, right? The first, the second, and the third. And then we have move 1 from 2 to 1, move 3 from 1 to 3, etc., etc. Okay, so all that looks good. And and what we need to figure out is what's on the top of each stack after we go through all the instructions. Okay, so let's take out print stacks. For instruction in instructions. Okay. Now let's see. We have quantity from and to. Oh, it won't let me do that. Okay, and let's rename this to instruction. Quantity stack from. Let's just make sure this works as I expect. Yeah, okay, good. Right, so we can just deconstruct the list that we get from this into individual values. Okay, so for we're just going to repeat. We want to repeat a number of times equal to quantity. Okay. Now the stack from and stack to, here's the thing. My stacks are being indexed 0, 1, and 2 because that's how Python treats lists. Here we're calling them stacks 1, 2, and 3. Does that matter? Yeah, that does matter because look, move from blah to blah. These numbers have to be the same as my index. So what I need to do is I need to subtract 1 from each of those values. Okay. Okay. So for each one of those, I'm going to do, what am I going to do? I'm going to pop from one and append to the other, basically. So I'm going to go the 2 stack. And I'm going to append like that. Right, so I take my list of stacks, I take the stack that we're moving to, and then I'm going to append the top of the from stack. So when you pop, it removes it from that list and returns the value. Okay, and that should do it. And so let's do that, and then we'll just print stacks at the end. And let's see what that looks like. So at the end, I get C, I get M, and then I get P, D, and Z. P, D, and Z. Okay, that looks good. So after that, stacks looks fine. And then the return value is going to be a join. And I just want to get the last element from each stack. So we'll do stack -1 for stack in stacks. So this will, if you use an index of -1, that just gives you the last element. So let's check that. CMZ. Okay. Looking good. All right, so now we can use the real data. So in this case, instead of the test data, we'll say get input. But in my case, I need to ignore the first lines. Yeah, see, you know, it's going to be hard to construct the stack from this. I think it might be easier if I just do that manually. I think, yeah, I mean, I think I could figure out a way to do this programmatically, but it might be easier if I just do it manually. Of course, if I screw up, then I'm not going to know that I screwed up. Okay, so in my data, the instructions are going to start with element 10. if we index from 0. All right, so that's going to be stacks. No, instructions. Yeah, I think I'll just build the stacks manually. Here, let's just paste that there for reference. All right. So the first one is going to be Z, J, and G. The second one is going to be Q, L. Whoops, you guys tell me if I make a mistake. R, P, W, F, V, C. Let's put a little daylight here. And then column 3 is going to be F, P, M, C, M, C, L, G, R. And then we got L, F, B, W, P, H, M. Sorry, guys. Yeah, arrays. Well, they are arrays, but in Python they're called lists. All right, GCF, SVQ, and then we got WHJ, ZMQ, TL. 3 more to go, guys. Ugh, this is tedious. H, F, SBV, F, J, Z, S, and then the last one, M, C, D, P, F, H, B, and T. Okay, let's check it. ZJG, QLRP, WFVC, FPMC, LGR, LFBW, PHM, GCF, SVQ, WHJ, ZM, QTL, HFS, BV, FJZS, and MCDP, FHBT. Okay, that looks correct. All right, that's our data. Hey, Robert. Yeah, we didn't finish Crastorio. It's a bit of a break. Yeah, I'm just doing some coding challenges here. Actually, once we finish this one, we'll get back to the Factorio. We did this a little bit in the last stream as well. So I'll keep going through these until I get all these puzzles solved. Okay, so that's the live data. Get input. So in this case, input is day 5. And I think we're ready to run. Let's see how we do. And I get an error. Index out of range. Okay. So let's try this. Let's make sure I have the data set up properly. Okay, yep, that is not good at all. How did I do that in day 4? I just did split lines. Okay. Okay, yeah, that was where I had problems. And actually, let me fix my template. Okay, so this is my answer. Let's see if it's right. Yay! Okay, we got it. Part 1 complete. Let's go to part 2. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane, and you quickly wipe it away. The crane is not a crate mover 9000, it's a crate mover 9001. So we have a version mismatch error. The crate mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder. That's nice. And the ability to pick up and move multiple crates at once. Okay. All right. So now the crates begin. Okay, so if we start again with our test data, moving a single crate works the same as before. However, the action of moving 3 crates from stack 1 to 3 means that those 3 crates stay in the same order. Okay, so when we move 3 from 1 to 3, instead of going first D, then N, then Z, it picks up the whole Z to D stack and puts it on top. Okay. So we're going to follow a similar method, but I mean, I guess it's not really a similar method. It's going to be a different method, but it shouldn't be too hard to do it this way. Okay, so now instead of doing pops and for loops, we are going to do, okay, so we know how many, we know what stack to take it from and what stack to put it on. Okay, so move stack is going to be stacks, stack from, and we're going to take a slice of it. Okay, so let's say if we're moving 3 from the from stack, for example, then we want the top 3 on the list. So we'll go from -1 minus. No, I think we just do minus quantity to -1. Right? Oh, sorry, that needs to be a colon, not a comma. Right, so we take, we're going to take the list from, yeah. Yeah, so if we only take 1, then we just get the last element. If we take 2, then it'll be the last 2 elements, and so on. All right, so that's what we're going to move from the from stack. And then we want, to remove those from the from stack, or the stack from. Right, so we'll change the from stack, and in this case we are going to go from 0 to minus the quantity. Is that right? -1, I think. And then the stacks, stack 2, and then we add the move stack. All right, so let's get the test data. And let's run it. And I get list index out of range. Okay. I'm getting list out of range here. So that probably means that one of my lists is empty at the end, which would be an error. All right, so let's take a look at our stacks each step. Oops. Okay, yeah, and this is what I get at the end. All right, so after the first step, I have, yeah, I have a problem. Wow. Yeah, this is not working at all. Okay, so the first one is the move stack, which I'm getting nothing. All right, so what if I do that? Okay, so in the first case, my move stack is D, which is right. From stack to stack. Okay, here, let's do this. I want to look at all the stacks in each step. Okay, so in the first example, my move stack is D, which is right. And then I have Z and D, M and P. Okay, so the C is not getting added back in. What happened to the C? Oh, okay. 0 to minus quantity. Yeah, I think that's my problem. Okay, yeah, now I get no error. So after the first step, I move the D, and I get Z and D, MC, and P. After the second one, I'm moving Z, N, and D together, and I get an empty stack, and then MC, and then PZ and D. Yeah, so finally at the end, MCD is what I have. Okay, so I think this is right now. All right, so let's try it on the real data. Oh, let's take out these, take out those print statements. But this is the answer that I get. Let's see how we did. Yay! All right, it worked. Okay, so I'll remove the test data. Yeah, and Mohad, I agree with you. This is kind of ugly, but but yeah, like doing this, yeah, I guess it could be, yeah, this would be a pain to do. Maybe not as much of a pain as this, but okay, so we're good. Day 5. Okay, I think that's enough of that for today. So let's fire up Factorial.